Welcome back to the whichermath channel. Today we are working on identifying proportions in graphs, tables, and in word problems or situations. Here's a practice test answer key, but you don't have to be in my class taking a test to get some support from watching this video. Okay, if you're just working on identifying proportions, this could be your thing. Here we go. So we're going to call this the answer key, and I'm going to write in red to make it look important, because it is. Okay, this time we're supposed to identify which graphs are proportional, and we're going to answer yes or no and explain. So we're going to identify and explain. Here we go. First, identify. No. Yes. No. Yes. See, if all we asked you to do was identify, then I would be done with this section, and you might not be sure why it's no or yes. So the explaining is so important. And here's the explanation. This one does not go through the origin. Remember, for a graph to show proportionality or a proportional relationship, it must go through the origin and be a straight line. It is a straight line, but you need both. Okay, that's why no. Next one is a yes. And this one is sort of tricky, or at least students get confused by it sometimes. Okay, it's definitely a straight line, right? It's straight. I'll run out of room there. I'll just put STR for straight. And here's the origin, right? And the confusing part could be if we use the word through the origin, you might think this is not proportional, right? Because we don't know if it's just starting at the origin or, in theory, if it would go, continuously. We don't actually know that unless we could see a table or read the situation that the graph represents. But just know this, if it's touching the origin and it's a straight line, that's okay. It doesn't have to literally go through it. The origin just needs to be part of the graph. Okay, enough about that. Next one. This beautiful curvy line, did my ruler slip? Did I want that to be a yes? Well, it doesn't matter because it's a no. It is a no. Why is that? Well, sorry, I keep moving the paper around. It goes through the origin. We like that. We're checking for both of these things every time, okay, if you didn't get that yet. But the problem is it curves. That means it's no. Okay? And finally, this one is a yes, but it also shows another thing that students sometimes get confused, which is, okay, it's going down, right? For some reason, people get it in their heads sometimes that when it's going down, for some reason, it's not proportional anymore. The key is it straight? Is it? Right. Yes. And is it going through the origin? Yes. And of course, the origin is the point 0, 0. It's where the x and y axis intersect. All right, so that gets us through the first section with our explanations. Let's move down to the can of corn. A 12-ounce can costs 90 cents. What's the unit rate? Show how you know. Typically, at the grocery store, I don't know if you noticed this, but I do. I shop for groceries for my family every week. And it's the cost per each ounce. So don't get this confused with how much corn can I buy for $1, for example. Cost per ounce. So if I've got, 90 cents, I'm going to go this way. 12 ounces, 90 cents equals 1 ounce is how much? Okay, we get that by just simply going 90 divided by 12, right? Because we're going to take those 12 ounces and cut it into 12 pieces, which gives us the 1 ounce. Cutting the cost into 12 pieces, not pizzas, yum, gives us the unit rate, which happens to be, in this case, 7.5 cents. Or depending on how you used your calculator, you might have gotten an answer like this, because you may have said 90 cents, right? Anyway, 7.5 unit rate per ounce. The corn, the 16-ounce can, the big boy. 16 divided by 1. And you might look at that and go, hey, the unit rate is 16. Yay! No. Remember, we're doing cost per ounce. The 1 in here means dollars. We're not doing cost per dollar. That would be a common mistake, and don't fall for it, right? If you're doing cost per ounce up here, you got to do it down here, or else, as they say, it's apples and oranges, right? So I actually do 1 divided by 16, which gets us this, or once again, depending on how you use your calculator, you might have gotten this. Once again, compare them. If you used your calculator this way, hopefully you used it the same way both times. So now we have a legit way of comparing our two answers. Okay, why do we need to compare them? Well, I kind of already knew what question 4 was. Which can of corn is the better deal? Better deal equals lower price. Okay, so that's tricky. We're so used to looking for greater unit rates and stuff like that, this might throw you. So pay attention to the words. Better deal equals what's the lower price? And as we can tell here, it's that one, which came from number 3. Number 3, the 16-ounce can. Explain or show how you know. Ta-da! There's no reason to do it twice. That's the beauty of if you show your work thoroughly and at a good level of detail every time. Often when you're asked to explain or show on a subsequent question, it's already there. You just have to be aware that it's there so you don't do it twice. Moving on, number 5. Explain or show how you can identify the unit rate and the origin in a table. Well, here's how. Unit rate is going to look like this. It's going to have a 1 on top and some value for y on the bottom, right? And that'll be in a table, okay? And then the origin, which we know from looking at a graph, is right here, and which we mentioned up here, looks like that as ordered pairs. Well, ordered pairs are just a table laying down, okay? So if it's 0, 0 up there, it's also going to look like that in a table. There we go. On to number 6. Getting my highlighter out. It's always fun to have a highlighter handy. Okay, fill in these tables. So these are our action words. Fill it in, circle the origin, and then shade or highlight the unit rate. Okay, we know from answering this question right here that unit rate is going to be there and there. Ooh, and we're going to have to put it in. We're going to have to fill it in there. It's not part of the table. Okay, so I already know that I'm looking for unit rate in those spots. Here we go. Part A, if I do 66 divided by 3, I get 22. That goes there. That's my unit rate. Oh, origin. It says circle the origin. Bam, bam, bam. Nice! We're already done with those. I'm so excited. Okay, once we have the unit rate, the cool thing is That's the multiplier, which we use to fill in all the other boxes as long as we're going that way. Okay? So 6 times 22 is 132. You knew that, right? And 25 times 22, I'm not going to pretend to be some kind of magician here. I'm going 25 times 22. Looks like 550. There we go. Let's move on to the next one. Did I do everything there? I circled origin, highlighted unit rate. Directions. Follow directions. It's great if you know your math. Follow directions. Sometimes it makes the difference. Okay, here I'm going to go negative 25 divided by 5, and that equals negative 5. That is the unit rate. That goes there. 2 times negative 5 is negative 10. Now, if I'm multiplying going that way, what am I going to do going the opposite direction? Right, divide. I'm going up. I'm going to divide by the unit rate. And same thing here. Good. Circle origin, highlight unit rate. Next. Hee-haw! There's a lot of stuff on here. I know it's a long video and everything, but geez, look at all this content. Wow. Okay, enough of that. Hey, what's the same about 3 and 10 and 5 and 16? Hey, how about it's times 3 plus 1? Sound good? Okay. Negative 5 times 3 is negative 15. Plus 1 is negative 14. Watch out. And if I'm going to work backwards, BW for backwards, then it would be minus 1 divided by 3. So 4 minus 1 is 3. Divided by 3 is 1. Oh, what is that? What is it? Right. Turns out we do have the unit rate. It didn't look like we did at first, so I was getting ready to do it over here. But we got it. Okay, moving on. Almost done here. Number 7. Are these tables proportional? Yes or no? Let's see. Yes. No. So we're supposed to answer and then explain. Always read the directions. Make sure you're doing everything that they ask you to do. How do I know? Well, there's an origin. And in this case, there's a unit rate of 3, right? Everything is being multiplied by 3. I could test that. How do I know? How do I know that? Well, if I take bottom divided by top, I get 3 every time. Okay, that's how you know. We're checking for origin and unit rate. That's our 2 things. Here is a no. How do I know that? Well, I have the origin, so that's good. But I don't have a unit rate, right? This is actually 2 squared, 3 squared, 4 squared, negative 3 squared. So even though I'm doing the same thing to each number, if you graphed this, it would look like that. It's a parabola. Okay, it's not a straight line, that's for sure. And if you need evidence, you could graph it. The other evidence is there is no unit rate. There is no multiplier happening over and over again. Okay, let's finish up. I know it's taken a long time, but wake up. We're almost there. Snurd ran at a constant rate. Ooh, that's a key word. Remember, constant rate means unit rate. He ran for 15 miles. Create a table that shows the origin and the unit rate. That means I need that and that. Question, how far did you run before any time elapsed? 0, right? So there's the origin. Unit rate, he ran at a constant rate for 2.5 hours. So we know 2.5 is 15 miles. So do 15 divided by 2.5 equals unit rate, which is 6. 6 miles per hour. Done. We did origin, we did unit rate. Next, Snurd ate Pop-Tarts. Constant rate. Once again, create a table. Just make it look like monster teeth in a cartoon. You got yourself a table. We need this and we need that. We know that it took him, do we want to do minutes or hours? Either one's fine, we just have to define it. I'm going to do minutes. Then I don't have to use decimals. Minutes, Pop-Tarts. Label stuff. Someone else might do it differently, right? If you label it, we can communicate. How many Pop-Tarts did he eat before the timer started? Good, none. That's the origin. Silly question, but it's always worth asking. We want the origin. It took him 45 minutes to eat 180 Pop-Tarts. So, if I divide Pop-Tarts by the minutes, that'll give me the unit rate. And I know 45 goes into 90 twice, and 90 goes into 180 twice. So 4. You could test that on your calculator. There we go, unit rate, which means he ate 4 Pop-Tarts every minute. That's 1 every 15 seconds. Yeah, Snurd, do it. There it is. Look at this. Look how beautiful that is. Thanks for playing. I hope that if you're in my class, I hope that helps you get ready for the test tomorrow. If you're not in my class, I hope that gives you a ton of information about identifying proportions in graphs, tables, and situations. Thank you for watching. Please subscribe. I will see you next time. Good night.